Okay, guys, just a little heads up. I'm switching things up. So now, assignments are going to be due the day that I assign them because a lot of students have decided to wait until Sunday to do everything. So they are due the day that they're assigned because you are supposed to be working every single day in your class. You don't want to skip because this is a full year course smushed down into a half a year course, which means when I give you assignments, it's like 1 to 2 days. When I go over a topic, it's like I would spend 1 to 2 days on it and I can't. I got to spend one. So every day is roughly about 2 days worth of work, which I've pared down. So keep that in mind. Make sure you get your work in. Today, we are going to be using your reference table page 6, so make sure you have it open. And we're looking at minerals in relations to rocks. So minerals are found in many different types of rocks. Looking at this, and if you were to look at page 6, you would notice something. Plagioclase feldspar, plagioclase or potassium feldspar, those are both minerals. How do I know? That would be on page 16. They are both there. Mica, whether it's muscovite or biotite, and quartz are also both minerals. And if you smoosh them all together to make this lovely looking rock called pegmatite. So there are some rocks that are monomineralic, which means they're composed of only one mineral. For instance, halite. Halite is only one mineral. Like it's the rock it makes up is rock salt. But most rocks are polymineralic, which means they're composed of 2 or more minerals. So think of minerals kind of like this. Letters make up words. So letters are to words as minerals are to rocks. So letters make up words, minerals make up rocks. Okay? All right, so how do we classify these rocks? 2 ways: how they're formed and where they are formed. So both of those determine if it's an igneous rock, sedimentary rock, or metamorphic rock. Today we're going to look at igneous rock, which is why you're looking at page 6 of your reference table. So igneous rocks form from the cooling and solidification of lava or magma. How you can remember this is if you look right here where it says has the magma going to igneous rocks, it says solidification. That's how you can remember igneous, cooling and solidification of lava or magma. There are 2 types of igneous rocks. The first type is intrusive, which means it cools inside the earth. Now, if you look at this little GIF right here, it says if magma never erupts, so it's like it's kept down in the cone of the volcano, it cools slowly in the ground and it becomes an intrusive igneous rock. So here's a couple different igneous rocks. Right here and here on the outside, smushing together the inside, you've got the light side, which is granite. What I mean by light side, we'll get to that in a little bit. You'll notice on this side that you have granite. On the other side, you have gabbro, which is the dark side. Yes, a little Star Trek, Star Wars, sorry, my bad, Star Wars humor. So gabbro, gabbro is the dark side, granite is the light side. And so the cooling that results in rocks that are cooled inside, they will have larger crystals. So intrusive, larger crystals. And the next type, so intrusive inside. Next one is going to be extrusive, exit, going outside, exit, outside. It cools on the surface of the earth or in the ocean, depending, semantics. So looking here, you have basalt. That is what the seafloor is covered with because of, we'll get to it, but the ridge in the middle, it forms new stuff, and that's typically basalt. Then you have rhyolite here. It is the lighter side of basalt. And then you have right here obsidian. Anybody who has played Minecraft may know that obsidian is formed when water and lava combine. Okay, so one thing you know is there's no shiny awesomeness here except for like a glassy look here. Fast cooling results in rocks that will have small or no crystals. There's like very little flakes you can see in here, and those are mainly biotite mica or amphibole. So just a reiteration, intrusive inside, extrusive outside. All right, so how do we identify it? These rocks, these igneous rocks? Well, color, ironically, proves to be very helpful. Remember, in minerals, do not go by color because they can be all sorts of colors. But with igneous rocks, color is very important because you have on one side, which is over here, the lighter side, which is pumice and rhyolite, and then you have the darker side, which is the basalt and gabbro, and this is, I think this one is periodite, which typically has the green in it. So how dark or light an igneous rock is suggests what minerals are in it. Okay, so looking real quick at this, page 6, it gives you this chart. It says the color side and the darker side. So on the lighter colored side, I'm just going to read it down. So there's potassium feldspar, quartz, plagioclase feldspar, biotite, and amphibole. Those are all considered the lighter side. Now on the darker side, you still have plagioclase feldspar, but you have pyroxene, you have amphibole, you have olivine, and then you have just this tiny sliver of biotite. Okay, so I'm going to still look at page 6. Do not look at page 6. Trust me. So texture. Texture proves to be helpful. So right next to texture on page 6, you have crystal size. So that's very important. And then all the way over here, it says where it's formed. So crystal size, looking at this has no crystal. It's glassy. This right here, it's not really in the texture side, but it is definitely in right up here. It says it right along there. That's vesicular. That's where you're going to see gas pockets, lots of holes. Pumice, think of pumice like pumice stone. If you ever have your feet done, they use pumice. It's holy. And then you have right here, this is fine, rhyolite. And then you're getting down into coarse, which it looks like you have like granite. This is granite, a little bit of gabbro, and then on the bottom, pegmatite is very, very, very coarse. I mean, you saw the pegmatite before. That was like super huge crystals and whatnot. So rate of cooling. Up here, typically, this is like super, super, super fast, very fast. Right here, this is just fast. Small, fine crystals, if that. Then you're getting into coarse, and very coarse. Those are slow. Well, all the way over on the side, it'll tell you where it comes from. Well, extrusive tends to be fast cooling. Intrusive tends to be slow cooling. All right, using page 6, we're going to answer these questions real quick. What light-colored igneous rock has fine texture? So look over here, fine. Go over to the light side. I'm connecting these two. Light side would be rhyolite or vesicular rhyolite. What size? The size of the crystals found in igneous rocks is directly related to where it is formed or how long it solidifies, how long it takes to solidify. What 3 minerals are found in the igneous rocks, granite, and gabbro? So again, I'm going to look up here, and it looks like it's just above 25%, because this is if you would impose it right down here. So right here, I'm looking across what matches on both sides. Well, I've got pyroxene. It looks like biotite, plagioclase, and that matches with that. Let's see if I matched up. Perfect. Plagioclase, feldspar, biotite, and amphibole. Oh, sorry. I put proxine. I did not mean proxine. Amphibole. I was correct. All right. So now we're going to look at these. Before I go to this, I do want to mention under lightness, you also have density. The heavier it is, the darker it is. The less dense, the lighter it is. And that also has to do with if it's felsic or mafic. Mafic is darker. It's got iron and magnesium in it. And then felsic has silicon and aluminum in it, which tends to be lighter. Now that we have that done, we are going to identify us some rocks. So scoria. Looking at scoria, I'm going to look for the first one right here, scoria. We have the dark side and the light side. Scoria happens to be on the dark side. It says that it's glassy, but if you look right next to it, it's pumice. And like I was saying with pumice, that has holy. So scoria is the dark side of the holiness. So which one of these is dark and holy? Number 4. All right, now we're going to look to rhyolite. Rhyolite is over here on the light side. So we're going to look at the light side. There's light, there's light. It might look like that's light. That's light. All right, so let's look over to texture. Let's whittle it down a little bit. It says fine. So it's not going to have big pockets in, like it's not going to have gas pockets. Because it doesn't say vesicular. It's fine, so like little tiny crystals. So that automatically crosses out 6 and 7 and 5. There's no gas pockets. 3's out, so I'm left with 1. Gabbro. So gabbro is the dark side of granite. And let's see, which ones are dark? Well, 2, 4, and I'm going to say 5 is dark. Well, we know it can't be 4. And gabbro says that it is coarse, so it definitely can't be 2 because that's glassy. So gabbro is number 5. Well, let's look at pumice. Pumice is light, and it tends to be the opposite of scoria. This is scoria with the pockets. The light side right over here at 3. Granite is the light side to Mr. Gabby Gabbro, which also this is gabbro, by the way. So number 5, it's the opposite of 5. Which one looks like the opposite of 5 that we haven't used yet? We're left with 2, 6, or 5. Or sorry, 2, 6, or 7. Well, 7 looks kind of similar crystal size. And that's it. Now, obsidian, one of my favorite rocks, because it's glassy in texture, number 2. And then we saw pegmatite to start this slideshow. It's number 6. All right, so now that you've gotten the notes, make sure you are looking over your notes. You have them written down. You've looked through your reference table. And do your Kahoot. Make sure it's public when you give me the link. Hope you have a great day.